In section 3.3, we're going to look at rates of change and behavior of graphs. And we'll first take a look at this quadratic function and determine how the function values are changing as x increases. And we will look from left to right, and we see that the function values are decreasing on the left-hand side of the graph. So we're going to say that f of x is decreasing from negative infinity to 1. Always refer back to the x-axis to determine the intervals. However, after this transition point, the function starts to increase. So we'll say that f of x is increasing from 1 to infinity. And another important location on the graph is this vertex, where the function stopped decreasing and started increasing. And this is called a minimum. It can be considered one of two options. First, it's a global or absolute minimum because it's the lowest point on the graph. And second, it's a local minimum. And a local max or min is just kind of a high or low point in a certain region of the graph. So that there's a minimum function value at 1, 2. Another important piece of information that we can gather from a graph is how, on average, the function values are changing. And so the average rate of change of a function on an interval from a to b can be found by calculating just the slope between those 2 points. And you can see that this ratio, delta y or over delta x, which is change in y over change in x, looks pretty much like the slope formula for a line. You can think of f of b minus f of a as y2 minus y1, and b minus a as x2 minus x1. Let's take a look at an example. We want to find the average rate of change of this function, f of x equals x squared, on the interval from x equals 1 to x equals 3. Okay, so I've drawn the graph of this function, and we're going to just label these ordered pairs at x equals 1 and 3. Algebraically, we can find those function values by substituting the given x into the initial function equation. So f of 1 is equal to 1 squared, and that's just 1. And therefore, the ordered pair 1, 1 is a point that's on the graph. The goal is to find the slope of the line that passes through those 2 points. Okay, and we can see already from that line that I've drawn that the slope is positive. And how to do that is we're going to use the average rate of change formula. So delta y over delta x is going to be, in this case, f of 3 minus f of 1 divided by 3 minus 1. We've already found f of 3 and f of 1, so now we're going to substitute those y values. F of 3 is 9, and f of 1 is 1. So we have 9 minus 1 in the numerator, divided by 3 minus 1, so we get 8 over 2, or 4. What this tells us is, on average, between x equals 1 and x equals 3, that y changes by 4 spaces for every change in x of 1 space.